recording now, and yeah, if you have a function that kind of looks like this, okay, going that way, and maybe like this, going this way, isn't that pretty? Okay. Then where this is the line y equals -2, and this is the line x equals 1, this line right here, okay? Is x equal 1, and this is the x-axis over here, and this is the y-axis. Then you have some things, just by looking at the graph, you can tell we talked about this in the last section. If this is f of x, the limit, if this function is f of x, the limit of f of x as x goes to 1 is what? As x goes to 1, what is that called? What's that called? Going down forever.
Negative infinity.
Right, negative infinity, and it's going up forever.
Positive.
Positive, yeah. So because it's going at two different things, and because it's going, at this point you just say does not exist. If you have an asymptote there, it does not exist. But then when we could talk about limits at infinity and beyond. Okay, 5x, that's Buzz Lightyear in case you're wondering. Okay, so as x goes to positive infinity, okay, like that, it's a sideways 8, right? Is then you get what?
-2.
Very good, Henry. It's going to -2, right? Because as this x value gets bigger and bigger and bigger, I get closer and closer to -2. You get that? Okay, and then the limit as x goes to negative infinity of f of x is also equal to, hello, as I get bigger and bigger and bigger this way, -2 as well. Okay, so that's what we mean by infinite limits, and that's what it looks like graphically. Okay, and then we have some definitions of those things. Okay, so the first thing says, and then we're going to do some example problems, which are fun, but believe me, no, really. So if where's my notes? Limit of f of x. Where's? Oh, if I want a different color. If r is a positive real number, if r is a positive real number, then that says number there, in case you're wondering. The limit as x goes to infinity of 1 over x to the r is equal to, guess what? What do you think there, Savannah? What do you think that limit is? 0. Very good, Savannah. Okay. And the limit as x goes to negative infinity
0
of 1 over x to the r, if it's a positive real number, what's that limit also equal to?
0.
0. Okay. So what kind of what that means is if I have something that looks like this, the limit as x goes to infinity of 1 over x to the 5th power. What's going to happen to this number as x gets very, very big?
It's going to be very much smaller.
This fraction is going to get smaller, 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 right? So if I put a 1 in here, I have 1. If I put 2 in there, I get 1 over 2 to the 5th, which is already 1/32, right? And then get smaller, smaller, smaller. And so this thing eventually goes to 0. Hey. Okay? And even if this number up here, the limit as x goes to, let's say, negative infinity of 3, let's say 16 over x to the 8th. Not -2, I mean negative infinity. Negative infinity. What's that going to go to?
0.
That's, hey, I'm going to move you guys again. this goes to 0, right? Because no matter how big this number is, when I take a big number and I raise it to the 8th power, this thing is going to be way, 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 way bigger than this thing, right?
No.
This is just, what?
What about if it's like 1?
If it's like 1, oh, good point. X has got to be, X is a positive, R is a positive real number. What if it is 1?
That is not one.
In the book it says
Oh,
that
it
has to
doesn't
be
matter
less.
because, yeah, if it's 1, it's going to start off where it's 16, right? But then as it gets bigger and bigger and bigger, it's going to get, that quantity is going to get smaller, smaller, smaller. Okay? So, and so you could use this to solve, use this idea to solve problems with involving limits. So find the limit, find the limit find the limit. Limit as x goes to infinity of 3x to the 4th, 3x to the 4th minus 5 over x to the 4th. So you can use this last rule that I just gave you to solve limit problems like this. And one way you can do it is by dividing everything. So I would just write this down. Divide by the highest power of x. Highest power of x. And everything, all terms. And so what happens if I do that, which you're allowed to divide as long as you divide everything. X goes to sideways 8 of 3x to the 4th divided by x to the 4th minus 5 over x to the 4th, that over x to the 4th. Okay? Now when I do this, what can I do right here for these ones? I can get rid of x to the 4th, right? So I get that's equal to the limit as x goes to infinity of 3 minus 5 over x to the 4th over x to the 4th. What's oh, I forgot to divide the bottom by x to the 4th. I'm sorry. Okay? X to the 4th. What does this turn into?
1.
That turns into 1. That's what, sorry. I messed up. So over 1. Now what does, as I plug in infinity here, what does this term go to?
0.
This term goes to 0. You understand that? Okay? Because this way outweighs this. So I get 3 minus 0 over 1, which is equal to 3. Right? Get it? So that's how you do that. Okay? Here, give me your phone. Come on, I'll give it back later.
I'll put it on that.
Let's try. I was going to throw it away.
Okay.
Cheese
No, that's my question.
Cheeses?
Yeah, cheese.
This is healthy to play for. Just
Oh, it is?
1
Okay.
point.
Next time.
You watch
Okay. So,
It's got diabetes.
the other thing, if I were going to graph this function, just so you know, would look something like, we'd have an asymptote here, and then it would look like this, kind of, and this would be the line y equals 3. So it would approach 3 from either side, okay? So you can look at it graphically as well. Now you could use kind of the same technique for finding limit problems like this. Find the limit as x goes to infinity or negative infinity will still work for x minus 1 over x squared. And you say, well, that looks pretty simple, but you do the same thing. You divide by the highest, you divide everything by the highest power of x. So what am I going to divide everything by? X squared. So I'm going to rewrite this as a limit as x goes to infinity, okay, of x over x squared minus 1 over x squared over x squared over x squared. And then I simplify this, okay, to what?
1 over x.
This simplifies to 1 over x. This stays as 1 over x squared. And this goes to 1, right? So when I plug infinity in here, what do I get?
0.
I get 0 minus 0, right? Because this is that first rule, 1 over something raised to a power is going to go to 0. This stays as 1. And you get 0 over 1, which is equal to 0. So this function does to this. Yeah, the answer isn't always 0. If you plug in it, so no, you're not going to get 0 in the next time. So let's just look at the next time. So what if I have the limit as x goes to infinity of something like x cubed minus 1, x cubed minus 1 over x squared. And you say, uh-oh, here comes this hard problem where I have to factor something, right? You don't have to factor anything. All you have to do is divide by the highest power of x.
0.
What's the highest power of x? No, it's not 0.
2.
See, the highest power, no, the highest power cubed. So what I'm going to do is I'm going to rewrite this as a limit as x goes to infinity of x cubed over x cubed minus 1 over x cubed over x squared over x cubed. I know you know a better way to do it, right? You know a better way to do it. But I'm just kind of showing you where this. So this is equal to 1 minus the limit, okay? Keep writing the limit. The limit as x goes to infinity of 1 minus 1 over x cubed over 1 over x. Okay? So, yeah. So this becomes, this is equal to 1 minus 0 over 0. What's 1 over 0? Yeah, that's undetermined. That's undefined. Okay? So for this one,
anything divided by 0.
you write
Don't know what
DME. Hey, can
like,
we just quit screwing around the entire period and try to
in the calculator it says
maybe
when
take
you
some notes or something?
turn
Okay.
Yeah, that's just when they plug into the calculator.
Okay, so that one would be undefined. So this kind of leads to 3 rules. See how this one is undefined or does not exist? See how the degree of this is 3 and the degree of this is 2. Okay? Going back, see how the degree of this is 1 and the degree of the bottom is 2 and the limit was 0. Right? This limit was undefined. And going back one to this last problem, the degree of this is what? 4, and the degree of this is 4, and the limit ended up being 3. So can anyone kind of maybe come up with a rule in your own words? Maybe?
Exponent minus
If n is less than m, there is 1, and if n is greater than m, there is 1.
Sort of. Okay. So if they have the same what?
It's the
If
they're the
they're
same,
exponent.
thing in front.
Yes, the
Okay,
coefficient.
so-
Oh.
Okay, so here's kind of the rules, okay? For rational functions. For rational functions, okay? Where f of x is equal to, I don't know, r of x over p of x, okay? Where these are polynomials. A rational function is a polynomial divided by a polynomial, right? Okay? If the degree So first rule is and it's the same rule as for horizontal asymptotes. If degree of bottom is higher than degree of top,
It's 0.
and degree of top, then the limit as x goes to plus or minus infinity
0.
is equal to 0. Okay? If degree of top, and they call this bottom heavy. Bottom heavy. Right? Because the bottom. So for example, let me give you an example so you have one. Okay? So if I have f of x equals 3x squared minus 2x. Oh, whoops. I missed. 2x over x cubed. What's the limit of this as x goes to infinity? What's the limit of that as x goes to infinity?
3. 0.
0. Okay? It looks like it would be 3, but it's 0. Because if you think about it, if I plug really big numbers in here, okay, like 100 and 100, when I cube something, right, it gets bigger way faster than if I square it and then multiply it by 3.
I thought that was a 2.
You see? So this bottom is getting way bigger when you get very big numbers. If I plug in 1,000,000 in here, this is going to be 1,000,000 to the 3rd power, which is going to have how many zeros? 27 zeros. This is only going to be 1,000,000 with 18 zeros times 3, you see? And so this number is going to way outweigh this number eventually, and so that's why that's going to go to 0. Right? Next, 2, if degree of top is equal to the degree of bottom, okay, then the limit as x goes to plus or minus infinity. That's not very good. I gotta look this way. The limit as x goes to plus or minus infinity is equal to the ratio of the coefficients of the highest degree terms. For instance, say you have the limit as x goes to plus or minus infinity of 7x squared, now 7x cubed, minus 3x squared plus 2 over 5x cubed. What's the rate? What's the limit?
7 over 5.
7/5, right? Because, right? Because as this number gets very large, and this number gets very large, these numbers become unimportant, right? Less significant, right? Because if I'm cubing them, so these things kind of disappear, and what you're left with is this thing is always 7 to 5 times as big as that. Okay? Yeah?
Wait, what about
The other stuff, because if I plug in some really big numbers in here, right, you'll see that these numbers become the squared and plus 2. It's insignificant.
Wait, isn't
compared
that
to
12?
cubed. What?
The 3x?
Oh, no, that's 2. Sorry.
Oh.
It just got messed up. That's 2. Okay? Okay. Give me your cell phone. You guys are unbelievable. Give me those cell phones. Give it to me. Give it to me. Give it to me. Okay? Stop. That's ridiculous. you too. And then you'll come and say, can I take a retest? I don't know how to do this. Sorry, I was playing on my cell phone the entire period today. You guys are like ridiculous. Okay. Anyway, rule number 3 says, let's get a different piece of paper. 3 says, if top heavy, if top heavy, so that's, I don't know what you call that, but if top heavy, if degree of top, if degree, I can't write very well, of top is greater than degree of bottom, then limit doesn't exist. Then D and E. Okay? For example, you want the limit as x goes to infinity of 6x to the 4th power minus 3x cubed over 273,424 x to the 3rd. What's the limit of that? D and E. And that doesn't, like I put some big number in front of here on purpose because even though this is just times 6, right? When you start raising things to a power and the numbers get very, very large, this goes up way quicker than this. So even if I cube something, like if this number is bigger, if x is bigger than 273,424 or something like that, then you're going to be raising that number to a big power, right? So this is going to go up bigger than this is, and so this is going to outweigh this, and the limit, this curve is going to go up forever like that.
Wouldn't it still have an answer though?
Wouldn't it still have an answer? No, it just approaches, just goes up forever without bounds. It's called, does not exist. Goes up forever. Where something that has a limit, it hits a specific line. You see? Okay, it has an asymptote. Really, that's what they're talking about. Okay. There is one more thing. It's with series, remember we talked about series? Okay. Yeah, so if you have something like a series, AN equals 3n over 2. A sub n is equal to 3n over 2. That gives you the terms. What's the first term? A of 1. Remember this from when we were doing series? A sub 2, A sub 3, A sub 4. What's the first term of this series?
3 over 2.
3 over 2. What's the next term? 6 over 2, right? Or 3. What's the next term? 9 over 2. Are these numbers getting bigger or smaller? These are getting bigger. So this series said to diverge, which means it doesn't have a limit. But if you have a series which has a limit, like, for instance, say you have, find the limit, find the limit of the converging series, okay, where A sub n is equal to 3n over n squared plus 1, okay? So what would be the first term of this series? A sub 1. If I plug in 1, what do I get out? 3 over 2. So it starts off the same as this one, right? What's the next term?
6 over 5.
6 over, you plug in 2, right? So it'd be 6 over 2 squared, which is 5, right? What's the next term? 9 over 10, okay? And then it's going to be 12 over 17. Okay? What? Not plus. So what's going to happen to this eventually?
It's not.
It's going to reach 0.
It's going to reach 0 because it starts out pretty big, but then it starts getting pretty small. So the limit of the series is going to be equal to the limit of this function, right? So the limit of 3n over n squared plus 1 And you can see since this one is bottom heavy, it's going to go to where?
Infinity.
It-
Zero.
Not to zero. Okay.
And infinity.
So the only kind of series that converge are ones where it's getting smaller each time. Okay? And that's it. That's all I have to yell at you about.
Sweet.
Okay, sweet. So how long did I talk for? 25.